Welcome to this live demonstration of systematic Figma to code development. Today, I'm going to show you the actual workflow we use to extract components from Figma and generate production-ready React code in about 30 minutes instead of days or weeks. This isn't a theoretical presentation. Everything you'll see is from a real project we're building. The components are complex, the requirements are demanding, and the timeline is tight. Perfect conditions to test whether systematic AI-assisted development actually works in practice. What makes this approach different is that we're not relying on AI to magically understand our requirements. Instead, we systematically extract complete specifications from Figma, provide that context to AI tools, and use verification gates to ensure we understand the code we're generating. The result is predictable, professional development that produces maintainable components. Let me show you what we're building today. This address selection component isn't just a simple drop-down. It's a 4-level hierarchical system where users select their region, then settlement, then street, then house number. Each level requires a separate API call to our backend, and we need progressive disclosure with automatic selection when only one option is available. The component must match our Figma design exactly, integrate with our existing TypeScript codebase and shadcn stores, handle loading states and errors gracefully, and work perfectly on mobile devices. Traditional development approaches would take weeks to get this right, involving multiple design review cycles and constant back and forth between designers and developers. But here's what we achieved. Complete implementation in about 30 minutes, 0 design revision cycles needed, perfect integration with existing code, and comprehensive documentation through Storybook. The key difference is systematic preparation that transforms AI assistance from expensive guesswork into predictable professional development. Look at these design variables: primary accent, input stroke, title large. These exact same names exist in our CSS custom properties. When the designer uses primary accent in Figma, the developer uses var, primary accent, in code. There's no guessing, no interpretation, no, this purple looks close enough. This shared vocabulary is what enables AI to generate components that integrate perfectly with existing code bases. Without it, AI tools generate generic solutions that require manual translation. With it, AI can produce code that looks like it was written by a senior developer who understands your design system completely. Not all Figma components are created equal when it comes to AI extraction. Look at this button component matrix. This is how you structure components for AI-assisted development. Every variant is defined as a property that maps directly to React props. Primary, secondary, ghost become the variant prop. Default, click, loading, disabled become the state prop. Boolean properties like showLeftIcon and showRightIcon control conditional rendering. Just like in React, the naming is consistent and predictable. Most importantly, everything uses design tokens instead of hard-coded values. When AI sees this structure, it can generate proper TypeScript interfaces, implement variant systems using class variance authority, and handle all the conditional logic correctly. The difference between this and typical Figma components is dramatic. Most designers create components that work great for design consistency, but provide no guidance for implementation. This approach creates components that serve as complete specifications for AI-assisted development. Here's what the generated documentation actually looks like. This isn't marketing material. This is the real output our script produces. Look at the component specification. Complete TypeScript interfaces with exact prop definitions, all variants and states documented with code examples, Design variables map to CSS custom properties. The magic is in the completeness. Traditional AI prompts give you fragments. Build a select component with multiple options. Our documentation provides everything. Exact component structure, all possible states, integration requirements with existing stores, design token mappings, and visual examples. This becomes the context that transforms AI assistance from expensive experimentation into predictable professional development. The AI isn't making architectural decisions. It's implementing detailed specifications. The result is code that integrates seamlessly with existing projects instead of requiring manual translation and refinement. The triple gate verification system is what prevents AI-generated technical debt. Gate 1 requires working code. It must compile without errors, render properly, and provide basic functionality. This is the minimum bar for any implementation. Gate 2 demands verified functionality. The component must match the Figma design exactly. All variants and states must work correctly, and integration with existing codebase must be seamless. This ensures business requirements are actually met. Gate 3 requires developer understanding. You must be able to explain how the component works, understand the architectural decisions made, and be ready to maintain and extend the code. This is often the most important gate because it prevents the accumulation of code you can't maintain. No gate can be skipped. This isn't bureaucracy. It's professional development practice. Teams that skip verification gates end up with code bases full of AI-generated code that nobody understands, leading to maintenance nightmares and technical debt that costs far more than the time saved during initial development. The systematic approach focuses AI on what it does best: mechanical implementation of detailed specifications, while keeping humans responsible for architectural decisions and quality verification. Let me show you the complexity hidden in what looks like a simple select component. Our requirements included supporting long lists, up to 300 street names in some Russian cities, with mobile optimization, multiple states, and integration with existing form systems. The AI-generated solution implements proper state management using CSS variables that map directly to our design tokens. Mobile optimization includes 33-pixel touch targets for comfortable interaction and native scroll performance without complex virtualization. The automatic icon sizing system ensures consistent visual appearance across all icons. What's remarkable is that AI-generated solutions for performance challenges we hadn't even specified explicitly. By providing complete context through systematic documentation, AI could anticipate requirements and implement appropriate solutions. This is the difference between generic code generation and professional development assistance. This comparison shows why systematic documentation makes such a dramatic difference. Traditional AI prompts provide minimal context. Build a select component with multiple options. The AI has to guess everything: component structure, styling approach, integration patterns, performance requirements. Our systematic approach provides complete specifications, exact TypeScript interfaces derived from Figma, all design tokens and variables mapped correctly, component relationships and dependencies documented, integration requirements with existing stores specified, and performance and accessibility requirements included. The result is AI-generated code that integrates seamlessly with existing code bases instead of requiring manual translation. It's the difference between getting generic solutions that need extensive refinement and getting professional implementations that work correctly from the start. Even with systematic preparation, things still break. The most common issues we encounter are color hardcoding, where AI uses hex values instead of CSS variables, tailwind version conflicts, where LLMs default to older syntax, state management complexity around component versus global store integration, and mobile performance, where AI over-engineers solutions instead of using native capabilities. The systematic advantage is that problems become predictable and manageable. When AI hardcodes colors, we have clear documentation showing the correct CSS variables to use. When tailwind syntax is wrong, we have established patterns to follow. When state management gets complex, our triple gate verification catches the issues before they become technical debt. Traditional development approaches treat these problems as mysterious failures that require extensive debugging. Systematic development treats them as predictable challenges with known solutions, dramatically reducing time spent on troubleshooting and refinement. Here's something critical to understand. The specific tools we're using today will change, but the systematic approach will remain essential. Today we're using Figma MCP for extraction, RooCode for AI assistance, Storybook for verification, and our triple gate quality system. Tomorrow's tools will be different. New AI models, enhanced design-to-code solutions, evolved verification systems, and improved quality frameworks. But the fundamental principles won't change. Systematic preparation, structured documentation, and human oversight will always be necessary for professional results. Teams that focus only on learning specific tools will constantly struggle with new technologies. Teams that master systematic approaches will adapt quickly to any new tools because they understand the underlying principles that make AI assistance effective and reliable. Let me break down what 30 minutes actually gets you with this systematic approach. Figma extraction takes 2 minutes through script automation. Documentation review takes 3 minutes to understand the specifications. Implementation takes 15 minutes, including row code generation and refinement. Gate verification takes 8 minutes for testing and understanding. Verification. Integration testing takes 2 minutes for final validation. What you get for that investment is production-ready components, matching Figma exactly. Complete TypeScript integration, comprehensive Storybook documentation, mobile-optimized performance, and most importantly, understanding to maintain and extend the code. Compare this to traditional development, where complex components take days or weeks, require multiple design review cycles, often end up with inconsistencies, and frequently result in technical debt from rushed implementation. The systematic approach isn't just faster. It produces higher quality results that are easier to maintain long term. The real value becomes apparent when you consider team scalability. Before systematic approaches, junior developers struggle with design implementation. Component quality varies dramatically across team members. Design-dev handoff requires constant clarification, and technical debt accumulates from poorly understood AI-generated code. After implementing systematic approaches, any developer can implement complex components consistently. Design system compliance becomes automatic. Clear documentation eliminates guesswork, and quality gates prevent technical debt accumulation. The result is teams that scale component development without sacrificing quality or consistency. Senior developers can focus on complex business logic and architecture, while junior developers handle component implementation using proven systematic processes. If you want to implement this approach, start with foundation setup. Install shadcn UI and the Figma kit. Set up design token synchronization. Create component documentation templates. and establish the triple gate verification process. Phase 2 focuses on tool integration. Configure Figma MCP or extraction scripts. Set up your AI assistance tool, whether that's RooCode or an alternative. Create Storybook validation workflows and train your team on the systematic approach. Phase 3 involves scaling and optimization. Refine documentation, templates based on results, build component library and patterns, create team onboarding materials, and continuously improve the systematic process. The key is starting small, with simple components to build confidence and systematic habits before tackling complex implementations like the ones we've demonstrated today. Try the systematic approach on your next project. Start small with one simple component. Use existing shadcn UI foundation. Follow the triple gate verification system and document what works and what doesn't for your specific context. Build systematically by creating your documentation, extraction process, training your design team on proper component decomposition, establishing quality verification workflows, and scaling gradually across your project. Remember that tools will evolve and change, but the systematic approach of proper preparation, structured documentation, and quality verification will remain essential for professional AI-assisted development. Master the principles, not just the tools. Thanks for watching this live demonstration of systematic Figma to code development. The next video will cover advanced RooCode setup and configuration for teams wanting to implement these workflows. This presentation and all the components shown were created using the systematic approach we demonstrated today. It's not just theory, it's proven practice that works in demanding production environments with tight timelines and high-quality requirements. Subscribe if you want practical AI-assisted development workflows that focus on systematic results rather than hype and magic promises.